Hi guys, I hope you're good since last video. We have seen AIDER in some previous videos. Here I'm going to show you another one that you can use as well. We will be going through how to plug it to Groq, and even better Llama.cpp, which is the base of all those frameworks that you see around OpenAI compatible APIs. Here the objective is not to make an app that works perfectly on everything. The purpose here is to show you how you can plug those in and have access, for example, with Llama.cpp to any Hugging Face model, which is amazing. And for apps, you know that you need iteration and good prompting with examples and so on. So here I will show you how you can get something running locally and completely private with your home computer. That is why I'm showing usually 7 billion parameter models, as those can run easily from home, while for bigger we use free APIs like Cerebrus, Groq, and now Gemini as well. So don't miss a piece and watch to the end to not miss any parts, as it is always little stuff that makes it not work as expected or as in the official documentation. Also, as always, please like and subscribe. Okay, let's get started. It is called GPT-Engineer. So it's been a while that it exists. It's part of the first frameworks that has been released. First agent framework, Agentic. Here we're going to use it as a CLI tool, as we did with AIDER. Okay, so the OG code generation experimentation platform. If you are looking for the evolution that is an opinionated managed service, check out GPT-Engineer.app. So they have a platform also for that. Okay, and those are the instructions in how to install it. You can pause the video to see those instructions, but I suggest you to follow just the way I'm doing it, because I will be plugging Groq and Llama.cpp. You can use it also through Docker. Docker is nice, but I don't want my video to be lasting like for so long, showing you all the different ways. So that's why I focus only on those two different ways, Groq and Llama.cpp. Okay, and here the pre-prompts. So vision also, for the vision models. Okay, vision capable models. This can be useful for adding UX and so on. They have a little video here. We start slowly, and after we're going to jump into the terminal. Okay, so that's how it is working. You see, it looks like just the way you're going to be prompting AIDER. I zoomed in a bit in the video, but it's okay. Just go into this GitHub repository to see all those different options that you can have, because we will be using it in a different way, because we want to plug it in some other softwares. So I'm just making a directory, GPT-Engineer. Let's go in. I'm going to use my Python 3.12. So that's where it's located in my computer. Because this server is running Python, which is older Python. So now you just use 3.12 or 3.13. And we create a virtual environment. As I told you, it's always good to create a virtual environment. We call it GPT-Engineer venv. And after you're gonna activate it with this command, so that you have encapsulated all your dependencies in one environment. to prevent any conflict with your server installed packages, for example. Doesn't mean you won't get any issues, but it's going to limit those issues. Okay, so we install GPT-Engineer. And after we can check if it is installed. Okay, this means it's installed, but that's not what I intended to do, because you need to put some commands after that. But here we just open the help page to see the different options that we have. Specify software, natural language, sit back and watch. The same as in the GitHub repository, that's what we got. Project path, those are the arguments. Model, M for model, we're going to use just model. Temperature, here we have the I for improve an existing project by modifying the files. Lit mode, run a generation using only the main prompt. Clarify mode, discuss specifications with AI before implementation. This can be nice. Self-heal, so to fix the code by itself when it fails. And after you have the provider, Azure, use custom prompts. Okay. I'm not gonna read everything, but you see here the different options. LLM via clipboard, use the clipboard to communicate with AI. So there's more options, as I told you. I didn't know the clipboard option, for example. You can use a prompt file. So this can be interesting to use. Entry point prompts. Okay, text file containing a file that specifies requirements. Image directory. That's for the containers. Use cache, no execution. So it looks like AIDER a little bit, because you can get your code to be executed. Completion, show completions. I'm even wondering if AIDER is not based on this one, on GPT-Engineer. Set the environment variables. I'm just trying here Gemini. I got this from the documentation. I'm just gonna not use the export, but use the .env file for the environment variables. And here I will be putting the API key. So what I've tried here is to just change the base API and the API key and the model. So I didn't show you, but I have populated those fields with the corresponding API key and API endpoint, and I'm trying to run it. So here we're gonna make, do I need to make a directory? Just to check if I need to make a special directory for it, or shall I just run it here from the root directory? Let's go around the idea of a recipe application. Just to have some context, we're going to try to make a recipe app. We don't care if the recipe app works or not. What we want just to see if those APIs are responding, because after that, as I told you, you just need to iterate through and to make it work with the nice prompts. So here we check if Gemini is going to work. So GPT-E, that's how you're going to start it. So starting from the recipe app folder, and after here I'm just going to prompt it straight away, so you will be seeing me using it the most native and simple way. And after the prompt here, it's going to be, I want to make a recipe application using Flask and SQLite. The application is using Google model. So even in the application, I want to use a Gemini. So I'm just going to ask it to do that. The application is using Google model Gemini 2.0 Flash Exp. After I simply ask for a nice interface, a web UI, but this can be more detailed in what you want. You need to have at least a prompt which is as long as one page to have all the different elements, the prompt, what is the best to have, the examples, and the negative prompt also. The application is a form in which user will enter ingredients, and after submission the user will get, and so on. Which we can make as a response, and also get a prompt. So while I'm writing my prompt, write yours. That could be used to generate an image. So this is what we've done in the other tests that when we tried those component generators, mimicking the Claude UI. So entering a prompt and getting the answer, plus the display of it. So here, as you can see, after having run it, it didn't work. I get a nice trace back of errors, but as you can see here, we don't get the right completion, because here it's going to be appending chat completions at the end, which is the OpenAI one. So Gemini API is not OpenAI compatible. So I tried to set up a service account, like in Kubernetes for applications, for example. But decided at the end to just go with next. So as it has to be easy wheezy. So this is, you can probably make it by going through the code and finding where to change the library and changing this code, but we won't do that. Please like and subscribe. And now let's go and start using Groq. This is the meat of the application. As you can see just above, there are those environment variables that I use for the Google version that I tried. It doesn't work like that. It's more complicated, and you don't want to stay in this for long. So here we just use Groq. We set the environment variable. You can pause the video and see what I've done before. You need to enter those keys, so I left it empty. Fix the typo here, OpenAI API key and OpenAI base URL. So you put the Groq URL and you put your Groq API key. So that's what you're going to do here, but using those two environment variables, OpenAI base URL and OpenAI API key. I tried to add a model, but didn't work. So here you can just use the flag model. So GPT-E, you use the flag lit. Use the flag temperature. We put the temperature at 0.1, and we use the model Llama 3.3 70B versatile. That's the model that we're using from Groq. The Llama 3.3 model 70B is a very proficient model also. So it's good to see them go into this competition, because we were getting amazing models being released every time, and they just keep improving. So it's using also, like a Mistral, those experts. So it's a multi-expert model. And here I'm just going to be writing the same kind of prompt, a Flask app with user being able from the browser to add ingredients and get returned a recipe. I'm asking for the model to be Gemini, just to use the Gemini API. And you see here, this works. At the time you got this, that means it works. So you could plug it in with Groq, and now you can start working on your application using all those options of GPT-Engineer. We got here the files created. Doesn't mean that the app works straight away. You might need to revise the app to go through and check. So here, for example, I'm not sure that this link is the right one, so you'll need to check the documentation, but you get a nice boilerplate quickly made in a second, and you might be able even to make it work, like to make it work actually without any issues. But after having those amazing prompts that you send on doing some iteration, so iterative process. So here it has created a bash script to run it. It has run it, but it doesn't work. Trying to install those requirements. Do not use in production. Might have worked. Quick check. I'm just gonna go through the code and those files that has been created. So you see here, we can see all the files created. So I just did that during the night. So here we have the templates, index.html, we have the statics files for the styles. So it has separated everything. It hasn't put everything in one HTML file, which is good. Little script. This is just my notes. So it's good also that while you're working on your projects, to have a file on the side where you put your notes about the issues that you have encountered, how you fix those issues, have your own documentation that talks to you directly. Because just going back to it, your brain is gonna remember those struggles, and you're gonna get your solutions coming out quickly. It helps also to make decisions. So here is the command that I've run in the terminal. So I ran GPT, I used the lit flag temperature, and I did the model name. Okay. And the model that I've been using here was Groq Llama 3.3 -70B-versatile. And it worked fine. Let's keep going. We check the code. Now let's fix. Let's try to do an iteration. I'm not going to do several iterations, but we can try. GPT, and here just put the model in. 70B versatile. You don't see the full screen, but it's okay. The left side is the focus. Hope that you're doing the same. I just pasted a prompt, trying to fix it on the top of the page. Okay. Google out. .env for the environment variables. I just asked to get those environment variables for the API keys instead to hard code it. And after here, it will try to run it. For sure, it's not going to work because I haven't populated any of those environment variables. But for me, as a developer, I get the boilerplate enhanced. And I don't know if I told it to use the Google generative package. But yes. So the imports are not right. As the documentation says, I'm communicating with you, just writing in the terminal. So that's not the right import to interact with Gemini. That's what I wanted to say. Here also there are some telemetry going on. So if you want to help the GPT-Engineer team, you can do that by sending them the informations. So here I'm just going to say, I'm going to run it again, another iteration, that's the third one. Fix the code for this project and add python.env because it is not in the requirements. Has been added to the code as an import. And I also ask for the Google Generative AI. Okay. So here we are done with the Groq. Basically, it works. I'm just playing with it a bit before going to the next step with the Llama.cpp, and I'm trying to get the best boilerplate ever. So another iteration for Groq. Let's just say update the code and the requirements.txt and .env file with this key. I'm just going to give a fake key. So I'm also testing it to see if it can do that. Because Llama 3.370b has its own reasoning, limits of understanding. Its ability to do tasks are not unlimited. So you need to push it just to see what it can do. Obviously, you will never share your key like that. But you can put a fake key so that it creates everything with those fake keys, and after you just come and replace those. Okay, set the project and call those in the code. We need to use python.env. I'll just keep repeating. So check if it is part of the requirements. Because what can happen when you're iterating is that the model just modifies what it has done properly previously for something wrong. So that's why you need to repeat. That's why what I suggest you to do is to have your page, your prompt in a page, detailed and to improve that prompt as you doing your iterations. And after going back from scratch, using that perfect prompt that you got at the end, and see if it creates the application from that perfect prompt. If it does, now you have something very valuable in terms of prompt. You put it on the side, you know that's when you want to create this, you can use that prompt. So that's how you can create your own libraries of prompts and test also new models when they come out, because you're going to reuse the same prompt that has worked before and see how the new model responds would need to be modified because of the architecture of the model, which can be different, or maybe you need less prompting, or maybe you need more details to it, or to prompt it in a different way, because the developers have already created a prompt template, for example, we never know, and so on. Okay, so here are my prompts. So do that just after having updated the 10th. So here I go more into the details. User entering the ingredient in a form and submit the ingredient as sent to Gemini /exp. Create an image out of the recipe. So I'm just asking for a prompt to make an image also, like we did in the previous videos. Requirement.txt need to have this package to interact with the Google API. So here I'm just providing the package to add, which is called Google-Generative AI, because it's been missing this one in the requirements. And I provide an example from the documentation of Google in how to implement it in the code. Okay. Here is the example. Just take it and work with that. I just use a /n for the line change. After, it's going to be able to figure out how to make it. Okay, API key. It's using my fake API key. Does not work as expected. Consider running the code in another way than above. For sure it's not going to work. It's a fake API key. So here is the .n file. That's good. Just need to replace those. Let's check the requirement, the txt. So you see it didn't add that Google generative AI package. So dependency. So here I find it a bit hard to add the dependency even if I gave it the example. So probably it's better to do it using a file template. Please like and subscribe. And we're going to jump into Llama.cpp way. It's another way. So the client need to install the client first. Pip install Llama.cpp Python. On the server, you do the same. Pip install Llama.cpp, and you put server between brackets. We check for Hugging Face model. Here I'm going to check for GGUF models directly, so I don't need to convert those, but you can use Llama.cpp to convert models from Hugging Face to GGUF, so you can do some conversions. There's a script in it that you can run. Here I'm just going to get here the Mistral 7b. Mistral 7b downloaded here. Just going to get the link and download it. So I'm making a directory called models, and I'm going to be cd to it to download the model in. So don't expect a 7B model to make an application. It's not going to happen, but you just see the process, how it works. Because I want it to download quickly. I don't want to wait for I don't know how long. And my computer is not that powerful to run super strong models. I'm just running it on a laptop at the moment. In the meantime, let's make those. So I'm just going to cd to model. Let's make a directory instead. Let's call it Llama.cpp way. Okay, now we're in the Llama.cpp. Home.py. Here I'm just gonna put some assertions and create a function above it. Sum two numbers. Why I'm doing this? Because I don't believe that it can create a recipe app, this 7B model. But it might be able to follow a prompt from this file. So python -m llama.ccp .server model path. So this is all coming from the documentation. And here you're gonna just replace the model with the model that you have downloaded. So you put the model path. Keep the end batch number to 256. So this is the path. Creditizens. And this is models. Okay, so here the download is done. I'm just gonna change the name of the model file because I add it at the end. Question mark download equal true, which is just just gonna get rid of it. I don't want this in the name. .gguf, it's fine. Okay, now we got the right model name. So now we have everything running locally because the model has been downloaded. We have the software. We have this, I'm just going to change it here. Write a Python script to sum up two numbers. Provide only the sum to number function and nothing else. I'm trying to provide instructions in this file and to prompt it. Just let's see if it works. If you can run it at least with GPT-Engineer. So what you need here is to run a server. The server is the Llama.cpp server. And after on the other side, the client is going to use the GPT-Engineer and it's going to be calling this server that you have created. That's how you can create your own instance. So models, here is the folder. It's not working, there's something wrong in my path. Let's get rid of this dash. Okay, now it's better. So it's not the model folder, it's the model file. You need to give it the GGF model. The environment variables, that's what you're going to be putting in your environment variables. For sure, you need to get rid. So let me do it right. So here I'm just exporting those variables. I'm not putting those in a file. So OpenAI key will be the server, which is running on localhost 8000. You don't need OpenAI keys. On your model name, you provide the model name. Now we can run GPT-E, the client. So let me get rid of this. I'm doing it intuitively somehow. So let me just grab the model here. Lit, temperature 0.1. Is it gonna work? No. Okay, let's change the command. So we might need here to put the flag model. Okay, has started, but is it gonna be able to communicate with the Llama.cpp server that we have running that model? Check the code in the prompt, .py file. Just let me say like that, execute the prompt.live.py file. Just saying, just execute it. It has called the v1 chat completion in the other side. The post request, we've received it. Yes, and now it starts working. Okay, so this is a success. We could connect to it. It's going to create some hallucinated code. It's not going to work. It's not going to create what I intended to create. But at least now we know we just need to prompt it the right way. And it's going to be able to work. It's creating those files. It's displaying some codes in the screen. This code is going to be put, I don't know why it's creating the script 1, script 2, and so on. And just printing hello from script 1, hello from script 2. So you see here that's a 7 billion parameter model. But you've seen how to do it. So now you can maybe use those Quen models, for example. So let's talk through the terminal again. It works. Now, depending on your hardware power. Okay. So you can download full powerful models to have a full private assistant endpoint for anything. So you can also see it in this way. You go on AWS, you create your server there, your instance with DNS, and you can access it from anywhere. And you have your own API, it's private. You put an authentication system in front of it, and you're good. Guys, I don't know if you realize, but this Llama.cpp is if you master it, you'll be able to convert models, create your own APIs, fully able to use it commercially, and load any model from Hugging Face. But the license will be binded more to the model you are using than the software you use to run it. Build with as less dependencies as you can to have full control of the product and use APIs for non-vital parts of your applications. That would be my suggestion, maybe, as those can stop running or change their rules or documentation or just stop being maintained and so on. Let's stop here for this video. Hope that you liked this video. Please like and subscribe, and see you next time.